All right, moving on to the reaction of alcohol, right? The first reaction is a substitution reaction, and an alcohol can undergo SN1 or SN2, depends on what it look like. If it's tertiary, it go SN1, secondary, primary, go SN2, right? And the whole purpose of doing substitution of an alcohol is to convert a poor living group. You guys know OH is a bad living group to a better living group, put something better on it, so we can do reaction on it. Okay, and the mechanism just like it. For example, we add an acid, hydrobromic acid. This is tertiary, going to go SN1. Protonation, you get a good living group here. Living group leave from carbocation and bromide attack. Okay, for SN2, this one is simple. Nucleophilic attack, you got a bromide, the good living group. Bromide attack the alpha carbon, so this guy leave as a water, so you get bromine on it. All right, super simple there. But practically, HBr works just fine, but HCl, hydrochloric acid, doesn't work that well. To be able to convert alcohol to alkyl halide, see how we do it. Right? So we're going to use the catalyst, zinc chloride, and this what does it do? Similar mechanism, OH attack the zinc, so you get zinc on it. This is a really good living group here, and then chloride attack. Ta-da! That's it. Super simple there. So for HCl, we have to add a catalyst to make it more effective. So we use zinc chloride to do that. Okay, so this is all substitution reaction. We also have these three reagents that we use to convert a bad living group alcohol to a much better living group. Let's take a look. Start with TSCl, thionyl chloride. We have seen this one time in the SN2 reaction, that's like chapter 7. What happens? So the alcohol will attack the toluene sulfonyl chloride right here. Chlorine comes out, so you get the retention product. So focus on the the stereochemistry. It doesn't change, so it's still up. This guy still point up, right? There's no an SN2 done on the alpha carbon of the alcohol. Now at this point, if we add a new chlorophyll, this is a really good living group. If we add a new chlorophyll, it will do backside attack or SN2 on the alpha carbon. So you got an inversion, right? I mean, just typical. Every time you do SN2, you get inversion product. All right, let's take review the mechanism together one more time. So alcohol attack the thionyl group. Got a negative charge on here. From the double bond right here, chlorine comes out. All right. And this is a pretty good living group now. Now, watch it right here. So we add the pyridine, which will act as a base, deprotonate that proton. You get the retention product. So that, from all the mechanism here, we haven't done an SN2 on the alpha carbon yet. Right? The alpha carbon doesn't do any reaction here. We done reaction on the oxygen. All right. So retention product here. Add a new chlorophyll, inversion. All right, now another reagent we have thionyl chloride and also add pyridine, same thing, that's the base, right? You're gonna go to this intermediate first. So basically the thionyl chloride gonna get on the oxygen, and then chloride nucleophilic attack on SN2, bam, you get inversion product. So watch out right here. If you use TSCl, the stereochemistry is retained. Right, retention product. But when you use thionyl chloride, there's a nucleophilic attack, the SN2 attack on the alpha carbon. So the chloride going to be inversion already. Right, so not retention like the TSCl. Right here, if you add a new chlorophyll, you're going to get a retention product. So same stereochemistry, because 2 SN2, we do SN2 twice on the alcohol. All right, let's take a look at the mechanism. So OH attacks sulfur and double bond break, right, go up to oxygen, right there. And then from double bond, one of the chlorine leaves. Here we go. And this is highly acidic right here. That's when pyridine comes in. So deprotonation, you get this compound. All right, so that's intermediate, and which is a really good living group. And the reason this guy going to leave, because right here, so chloride will attack SN2, backside attack on this carbon, invert the configuration, and look at the product. We have sulfur dioxide. Any reaction that produces gas, that's gas like bubble out of the solution, so it leaves solution. Basically, that's one of the great driving force right? And so that's what that's a reaction mechanism. Okay, so if you use SOCl2 thionyl chloride, there's one SN2 backside attack right here on the alcohol. So the initial product going to be inversion product, right? Not retention product like a TSCl. Lastly, this one similar to SOCl2. We use PBr3. You're going to get this compound first, right? And then bromide will attack. The leaving group leave. You get same thing. This is an SN2. Just like SOCl2, you're going to get bromine onto carbon inversion product. Yeah, because there's an SN2 right here. TSCl doesn't have SN2. If you add a new chlorophyll right here after that, you will get a retention product. Let's take a look at the mechanism. So there's one SN2 right here. Let's see. Nucleophilic attack first, right? Not the stereochemistry doesn't change yet. So because there's no backside attack on this carbon, not yet. And then here we go, backside attack. All right. This is how we're gonna use all of this. All right.